Hello everyone, welcome to my chemistry channel BL the Short and Sweet in Chemistry. Now I am going to explain the chapter Coordination Compound for class 12th, which is according to CBSE syllabus. Now my topic is the part 7b Geometrical Isomerism having coordination number 4. The coordination compound, if the coordination number is 4, what is the geometrical isomerism here will take place. Now actually geometrical isomerism undergoes stereoisomerism. What is stereoisomerism? It is a part of the isomerism. Isomerism are two types. One is structural isomerism, other one is stereoisomerism. Structural isomerism where structure is different, arrangement of atoms are different, and stereoisomerism arrangement of atom in space is different, and that is why it is called stereoisomerism. In stereoism there are two types here, one is geometrical, other one is optical. Now we are going to see the geometrical isomerism. In geometrical isomerism, what are the position, what are the types? One is cis isomerism, other one is trans isomerism. Then cis means what? Cis means the ligands which will on the adjacent side. See here in the below you can see last line. Here these are the adjacent side. These are also adjacent side. So it is cis. Now the ligands are opposite to each other, or it is called diagonal. In diagonal form, so it is called trans. That means stereoisomerism are two types, geometrical and optical. Clear? Then geometrical isomerism is cis isomer and trans isomer. Cis means adjacent side the ligands are present, and trans means ligand on the diagonal side or opposite to each other. Then occurs this isomerism, geometrical isomerism, where you will find, actually you will find in square planar complex and octahedral complex. Square planar means the structure, octahedral means the structure of the complex. If the coordination number 4, then what is the possible structure? Square planar. If the coordination number 4, what is the possible structure? Square planar. If the coordination number 6, what is the possible structure? That is the octahedral. So here coordination number 6, here this is the actually line goes to like this. So if the coordination number 6, then it is octahedral. Here the example I have given this ones after square planar. Now if the coordination number 4, that structure is square planar, example this one, Ma2B2, M is the ligand, M is central metal atom, A is the ligand, B is the ligand. A2B2 mean what? Two types of ligands are there and they are 2 in number. Now see here this square planar means this is adjacent side and this is the adjacent side, so cis. This is diagonal to each other, or you can say opposite to each other, that is called trans. I hope it is clear. That means geometry, first you will see isomerism. In isomerism there are two types. One is stereoisomerism, other one is structural isomerism. Structural isomerism are so many types, generally linkage, coordination, ionization and solvation. In stereoisomerism there are only arrangement of atom in space different, and that is why stereoisomerism are again two types. One is geometrical, other is optical. In geometrical, cis and trans are there. Now we are studying the geometrical. After completing this one, we will go to optical isomerism. Geometrical isomer main factor is that means the two diagonal adjacent side present and two diagonal may be diagonal to each other present. If they are adjacent side, this is called cis form. If they are diagonal to each other, or you can say opposite to each other, that is called trans form. So you can say geometrical isomerism is cis trans isomerism. Now we will see the examples of the complex where the coordination number 4, and how can we explain the square planar complex, square planar structure for the coordination 4 in the coordination compounds. Here we will see types of square planar complex where MX2L2, that means two types of ligands, but they are similar in nature. They are same, not similar, they are same. And here the coordination compound is Ml2XY, where L is the ligand, that is same in 2 number, where here MLBX2, where the X is the same ligand 2 times, and here nothing is same, not repeated. ABYL4 ligands are different. Then first you will see MX2L2. Then what happens here? That means 2 ligands same, and that is why you take example CONH3 2Cl2. That means 2 ammonia ligands and 2 chlorido ligands are surrounded by the cobalt +2 charge. Coordination number is +2. Because ammonia is a neutral molecule, that value is 0, neutral molecule, neutral ligand, and whereas chlorido is a anionic ligand where charge is -1, so it is -2, and it is 0, that is why it is +2, so that the value is 0, that is a neutral complex. What is the name? Diamine dichlorido cobalt 2. Cobalt 2 is the Roman numeral. So, diamine dichlorido cobalt 2, and it is a neutral complex. Then come to structure, the square planar structure. This is a square planar structure where chloride, or you can say chlorido ligand, that is in the same adjacent side, ammonia ligand, that is in the same adjacent side. This is called cis isomer. And here the ammonia ligand opposite to each other, or can say diagonal to each other in the coordination complex, that is square planar structure, where also chlorido, 2 chlorido ions are there, they are also diagonal to each other, that is called trans isomer. So it is called cis isomer, it is called trans isomer. And now next example, the second one, see here, the platinum. Platinum is a central metal atom where pyridine, that is a neutral one, the charge is 0, and chlorido is a anionic -1 charge ligand chlorido. Pyridine 0, chlorido -1. Now pyridine if is 0, chlorido is -1, so the value comes to -2. And here the charge of the complex is 0, that is a platinum oxidation number +2. Platinum oxidation number +2, or you can say Roman numeral, that is 2. So what is the name? Dichlorido, pyridine and chlorido first will come. So C will first, that is why dichlorido, dipyridine, platinum 2. Again see dichlorido, dipyridine, platinum 2. Then come to structure. Whether you write pyridine on one adjacent side and chlorido in one other adjacent side, then what happened? You can observe that it is called cis isomer, because chlorido group, 2 groups, that is same adjacent side. Similarly pyridine also on the same adjacent side, that is why it is cis. Whereas where you can find here pyridine opposite to each other, diagonal to each other, and similarly chlorido group also, that is diagonal to each other, that is why it is called trans isomer. Next we will see example Ml2XY and others. So first I will start Ml2XY. Now second example is Ml2XY. L is the ligand in 2 times, XY a different ligand. Example C, CO, ammonia ligand is surrounded by cobalt, that is 2 times, 2 ammonia molecule, chlorido 1, bromido 1. So what is the name? Diamine bromido chlorido cobalt 2. Again see L2, same ligand 2, ammonia 2 times, X suppose chlorido, Y suppose bromido. Then what is the name here? Diamine bromido chlorido cobalt 2. Now example, here you can see how can you write cis and trans isomer. Ammonia, the same adjacent side, and chlorine bromine, there are different ligand, chlorido bromido. So it is cis isomer because I focus to ammonia, which is 2 times, that is cis isomer. Now I focus to ammonia, which is diagonal to each other or opposite to each other, that is a trans isomer. You write X and Y, that is chlorido and bromido, in opposite side. But remember our focus should be ammonia, because here ammonia, due to ammonia it is cis isomer, so due to ammonia it should be trans isomer. Suppose another example where pyridine 2 times ammonia and chlorido, ammonia and chlorido, that is PY, pyridine 2 times, so I will focus to pyridine as your cis isomer as well as your trans isomer. So try to write name and try to write structure like this. Number 3, MLBX2, this is same type, MLBX2, that means L is a ligand, B is a ligand, X is the ligand, but it should be whether halogen group. So you see PT and ammonia, 1 pyridine and 2 chlorido. 2 chlorido, that is -2, ammonia is 0, pyridine is 0, so it is, the value is 0. So what is the name? The name is, you write yourself name, what is the name? It is ammonia, amine first, pyridine, chlorido, dichlorido, chlorido. So amine first, chlorido second, alphabetically pyridine third. Like this you write the name, that is amine, chlorido, pyridine, platinum 2. Amine, dichlorido, pyridine. Again amine, dichlorido, pyridine, platinum 2. And so here according to this you can write LX2. X2 mean, here write XX. You are focusing to X as a cis isomer. You should focus to X as a trans isomer. You believe you focus to X, that means X will form cis and X will form trans. If X ligands that will adjacent to in one side, adjacent side, then cis. If X ligand opposite to each other, that is trans isomer. Next is MAABYL. A different, B, Y, L, all ligands are different. What to do then? Now here you will fix one ligand, that is the position of this ligand. I will focus this ligand. Yes, it is the position here. To keep this ligand in a fixed position, you should write other ligands and try to change the ligands. Let us see, ammonia is fixed in this position. Then what are the remaining? You write NO2, water, PY as you like. Now ammonia and NO2, think yourself, ammonia is our ligand, ammonia is focusing to cis ligand, cis isomer, then what to do here? What is present here? That should be cis form. Then you think yourself, if ammonia is there with me, ammonia is a fixed one, then what to do? You write any ligand out of 3 and think yourself this is the cis. Next same time you write the same as a cis, and only you interchange the ligands, pyridine and water. Water above, pyridine below. That means PY above, water below. So this is the trans. Because why it is it is cis. Why it is cis? Both are cis. Because I fix ammonia here and NO2 here, automatically 2 ammonia nitro group is there. That is why this is the cis. Only interchange of these 2 ligands. Then what is trans? Trans means what to do, since ammonia and NO2 group they are adjacent side and they are cis form, that is why you change this one, PY to here, NO to here, that is trans. That means NH3 NO2, because we fix NH3 NO2 as a adjacent side, that is why this is again trans, opposite to each other, and like this you put this is trans. Again try to understand here correctly. A, B, Y, L, 4 ligands are different. That is why you fix ammonia, any ligand you fix here, and other ligands you write, and try to see here what are the present, what are the ligands present, NH3, NO2, that means cis. Only you can change this one. Yes, it is changed. So there are 2 type of cis isomers. Now after that, NH3 NO2 you think that is a cis isomer, that is in adjacent side, that is why you keep in opposite side, diagonal side, and here only pyridine only interchange, automatically ammonia NO2 that is present in opposite to each other, that is trans side. So I hope it is clear. and actually example 1 and 2 are very easy, and 3, 4 and fourth one is little difficult. You should fix in your mind this is fixed and what should be in adjacent side. You think this is in adjacent, again you write this as adjacent side and interchange the ligands. And third one, trans isomer, you think if it is adjacent side ammonia and nitro, again I will write this ammonia and nitro in opposite or diagonal to each other act as a trans isomer. I hope it is clear to you, and that is coordination number 4. If, then what are the square planar complex possible? There are 4 types square planar complex are there. One by one I have explained. In coming video I will explain the geometrical isomerism in if the coordination number 6, that is octahedral complex. So hope you will subscribe my channel BL Das short and sweet in chemistry, and also I may hope you will like and share my channel. Thanks for watching my video. Thanks again to all.